Okay, we are now recording. Let me get a swig of water. I ate a couple of goldfish in between the classes. Oh, here's Jared. Jared is coming in. Let me get him here. Jared's here. All right, that should have us up to 3, 4, 6, 9, 12. That should have 12 students here. Yep, I'll make 13. All right. Any questions, concerns, problems, issues? All right, where we left off last, oh, here comes Azora. So let me get her marked here. Good deal. So now we're up to 13 students, 14 total it should be. Yep, it is. Okay, any questions, issues, concerns, problems?
Did you give me Dr. Fowler?
Who is this?
Azor.
Azor, yes, just had you. I saw you in the waiting room and marked you then. Thank you. All right. Yeah, I only Zoom, I don't know what it is because I have PowerPoint up. I can only see 4 names over on the side, my ugly picture plus 4 names. And if you're not one of the 4 names, I can't tell who's talking. If I had the, what they call it, gallery shot, I could tell who was talking, but because we have PowerPoint up, they only show 4 at a time, so I couldn't tell. All right. Any questions, issues, concerns? All right. We're in Chapter 4, Trigonometry, in Section 4.5, which is Graphs of Sine and Cosine Functions. We got started in this last time, and we're continuing now. What we're doing before, we talked about the basic shape of sines and cosine function, the sinusoidal curve, and then we talked about increasing amplitude or the period. Now, the amplitude was a vertical stretch or shrink. The period was a horizontal stretch or shrink. Okay? Now we're going to get into translations. This is shifting them one way or the other. Now, back in Math 112, you basically dealt with the shifts first and the stretches in non-rigid transformation second. This one we did non-rigid transformation first, amplitude and period, and now we're doing the shifts, okay? And these are called translations of sines and cosine curves. It won't advance until I click on the slide and then advance. Okay. The constant c in the general equation, now remember, y is equal to a sine bx minus c, or y is equal to a cosine bx minus c. Now again, if you remember, I said I like to pull the b outside the parentheses, so that makes what we're calling, the book is calling c here, actually what I call c is what they call b over c. And you'll see why, and why they don't do it this way. They're not physicists, and I think that's why. But this creates a horizontal translation or a shift in the basic sine function or the cosine function. And if you remember from back in pre-calculus algebra, anything you do to the x's is always backwards, okay? We talked about that with the b. If it's a big B, you got a horizontal squeeze. If you got a small b, it's a horizontal stretch. It's backwards. Well, the same with the c here. If you get a minus c, you're shifting to the right c units, not quite. We'll talk about that. And if it had a plus there and c was positive, you'd be shifting to the left. That's a horizontal shift of the basic sine and cosine curves. Now, and this is where the way they do it makes it so awkward. If you compare y is equal to a sine bx with y is equal to a sine bx minus c, you can find from the graph of this completes one cycle between bx minus c equals 0 to bx minus c equal 2 pi. And then they solve for x. So they add c to both sides, and you get bx is equal to c, and bx is equal to c plus 2 pi. Then divide by b, and you get x is equal to c over b, or x is equal to 2 pi, c plus 2 pi over b, which is really an awkward form. So that's what we're doing. So it's either c over b less than or equal to x less than or equal to c over b plus 2 pi over b. Well, now this 2 pi over b, that was your indicator that you got a horizontal shift or spread. That was what we dealt with the period. 2 pi over b is your period. But why in the world wouldn't they just call this, take the b out of the parentheses, that would leave this exactly the same, and then your c would be here, and that would be what I call the phase shift. They call c over b the phase shift, and it just is a more awkward way to doing it. So this implies that the period of y is equal to a sine bx minus c is still 2 pi over b. Nothing changed with that. It wouldn't have changed if you put the b outside the parentheses. Nothing would have changed. And the graph of y is equal to a sine bx is shifted by an amount c over b. If you had pulled the b on the outside, then that new constant on the inside would be what they were calling c over b, I would call c. And it would be so much easier to deal with. So that number, c over b, is the phase shift. That's exactly what I called it. If you had pulled the b on the outside, then what's left on the inside would be the phase shift. That's what I usually call the c. Of course, I'm coming from a physics background, and oh, here comes Damien. So let me get Damien here. Good deal. Okay, we're only missing Morgan, Courtney, and Sharika. Okay, so hopefully they will be coming in later. Okay, so any questions so far on translating, and these are so far horizontal translations of your sine and cosine curves. They've been focusing more on sines, but same thing holds for cosine. It won't advance until I click on the slide. It's sort of crazy that way. So here is the box in the middle of page 301. The graphs of sine and cosine function. By the way, I forgot to say to Damien, we're in chapter 4, trigonometry, section 4.5, and here comes somebody else. Morgan's here. Good deal. Okay, let me get Morgan marked here. Now, boy, top part of the alphabet, everybody's here. The last two, not. Courtney and Sharika, hopefully they'll be coming in. All right. So everyone who just got here, we're in chapter 4, trigonometry, section 4.5, graphs of sine and cosine functions. We're on page 301, the box that's just about the middle of the page, the upper part of the middle of the page. Graphs of sine and cosine functions. The graphs of y is equal to a sine. Now, if I were doing this, I'd put the b on the outside of the parentheses and have just x minus c in here. They put the b on the inside, so it messes everything up. Or y is equal to a cosine, same thing here, bx minus c, have the following characteristics. What we've done before, the a here indicates the amplitude. The absolute value of that a is your amplitude. The period is still 2 pi over b. And it would be if we took the b outside the parentheses. So I see no advantage of having it inside the parentheses. But The left and right endpoints of one cycle interval can be determined by solving these equations, bx minus c equals 0 and bx minus c is equal to 2 pi. That makes one period, okay? And we've already one cycle, okay? One cycle is what I meant. And we already know the period is 2 pi over b. We had that from before, dividing both sides by b. The phase shift is at c over b. If they had written it properly, it would just be c. But they don't. They do it this way. All right. So here's example. They're skipping example 4. So let's go back and do example 4. Okay, let me get my handy dandy little pad here. And it says, analyze the graph of, let me get the book in my lap so I can read better. There's a lot of glare coming in from the window. Oh, yuck. Hold still. I've got to move some things around. This toolbar, taskbar, they put down in the white space, which it shouldn't be. I think I've already scooted y'all as far as I could. So let me scoot the whiteboard to the left and up as far as I can get away with. Okay, that looks good. You probably couldn't tell any change at all, but it's the change on my screen. Analyze the graph of this. Y is equal to 1/2 times the sine of x minus pi thirds. X minus pi thirds. Okay. Now, the book's heavy. Let me get it out of my lap. I like to start at the beginning, right here. Your A is equal to, this is aggravating, A is equal to my board's moving around on me. 1/2. I wrote 2 near the top. Okay. A is equal to 1/2. That means the amplitude is 1/2. So your amplitude is the absolute value of that, 1/2. Okay. Remember that. We'll come back to it. What's your B here? B is equal to 1. Coefficient of 1. That implies the period is 2 pi over B. Well, B is 1, so that's just 2 pi. Normal period for a sine curve. But your C here is pi thirds. Not minus pi thirds, but pi thirds. It's always assumed to be a minus sign. So this is pi thirds. That's your phase shift. And the main reason it's the phase shift and not, this is so aggravating. Okay. Because the B was 1. So you don't have to worry about having C over B because that's still pi thirds. So this is called the phase shift. Phase shift is pi thirds. Now that's important. Okay? We'll get to that in a minute. Let's go back here to the period. The period is 2 pi. That makes our interval, our horizontal interval, you divide that by 4. So that will make that pi halves. Okay. Now, here's the problem. Your phase shift is pi thirds, your interval is pi halves. We have to deal with least common denominator, and that would be 6. So my interval now is going to have to change to pi 6. Okay, so I'm going to draw my graph. That's supposed to be a vertical line. It's not very vertical, is it? Okay, that's going to be my horizontal axis, the x-axis here. That's not too good either, but maybe a little more horizontal than that was vertical. So our tick marks here, I just start ticking off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, maybe even 14. Do in this direction too. Negative 1, 2, 4, 5, 6, 7, 8. Whoa, here comes Sharika. Good deal. Now we're only down to Courtney. So hold on a minute, folks. I need to mark Sharika here. This is fantastic. Y'all are a great attending class. I love to see it. I don't know if my pen just died. It looks like it did. Well, no, it didn't. Sharika, you're forcing me out of ink. Okay. We're only missing Courtney. Hopefully he will get here. Okay. Sharika, we're doing example 4 on page 301. We're in chapter 4, trigonometry 4.5, graphs of sine and cosine functions. And we're doing example 4, the bottom half of page 301. Okay. And I was just drawing the axes for it. Probably got these too close together. Let's go up here. These are going to spread out some. I can scale it however I want to. Okay. Now, let's do the vertical scale. That's easy. That's the amplitude. This is 1/2. This is 1. This is minus 1/2. And this is minus 1. I knew that was going to be because the amplitude minus 1/2, or is 1/2. So I wanted to get those in there. Okay, now, normally I do my interval of pi halves because it's a quarter of your period, but we have a phase shift of pi thirds, so we need to get our intervals here are going to be, I'm still going to use pi halves, but I have to mark them in 6 of a pi. So this will be pi 6, this will be pi thirds, this will be pi halves, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. This will be pi. 1, 2, 3, 4, 5, 6. This will be 2 pi. Remember, each of those ticks is a 6 of pi. This is minus pi 6, minus pi thirds, minus pi halves, 3, 4, 5, 6, minus pi, 1, 2, 3, 4, 5, 6, minus 2 pi. Okay. Now, start with the phase shift. That's pi thirds. To the right, because it's a minus sign, remember, to the right, that's where we start. Where does sine usually start? At 0. Okay. Now we go to our intervals, pi halves. Since we have pi 6 as the markers here, we're going to need 3 6 of a pi to be pi halves. So we'll go 1, 2, 3, and by this time it's gone up to the amplitude, 1/2. Okay, 1, 2, 3, it comes down to the origin again. I mean to the x-axis again. 1, 2, 3, it goes down to the amplitude, minus the amplitude, minus 1/2. 1, 2, 3, it comes back to 0 again. Going in the other direction, from here, that's where we began, 1, 2, 3, it goes down to minus 1/2. This is just not drawing well. 1, 2, 3, up to 0. 1, 2, 3, up to positive 1/2, somewhere right around in there. I'm off now. 1, 2, 3, 1, 2, 3, back down to 0. Yuck! One, two, three. 1, 2, 3. That's 0. 1, 2, 3, down to minus 1/2 again. So here's what that sine curve looks like. It goes up here. Remember, always to make these curves smooth, never pointed. That was a little too pointed, but always smooth and continuous. Hit each of these points here, smooth and continuous. I missed it a little bit, missing that one too. Down here, and then bring it back up to there, somewhere there it's supposed to be. There it is. So phase shift, you see, sine would normally begin right here. It begins over here. Phase shift, pi thirds to the right, so everything gets moved to the right, to the plus side, pi thirds. The reason I did pi 6 is not because it's my interval or my phase shift, but that's the least common denominator between my interval and my phase shift. And then I count everything according to, once I get that pi thirds in place, then count over how many 6 of a pi is pi halves. That's my interval. So the interval is still pi halves, but we're measuring in 1/6 of a pi, so that would be 3/6 of a pi. So that's why you count over 3 spaces and then go up or down or on the axis or wherever. Does that make sense? All right. I hope it does. I hope you're not just being very shy. You can look at their figure in the book and you see they did it fairly similarly. There is a checkpoint at the bottom of the page. I would highly recommend you do the checkpoint. Now, example 5, they're actually doing on the PowerPoint. So let's go back to the PowerPoint. 4.5, I think, was this one. Yes. Okay. Sorry. I don't know if the fact that it's cooler today or the fact that I was outside all weekend and pollen and all sorts of stuff, but my head is completely clogged up. And water alone doesn't seem to cut it. So I need just a little bit of carbonation there. All right. We went over this slide before, so let's move on to example 5, top of page 302. Sketch the graph of this one. Y is equal to minus 3 cosine of 2 pi x plus 4 pi. Now, I'm not going to do it the way the book does, okay? I'm going to rewrite this by factoring out the b here. And that will give me a new c. This is what the book is calling c. I'm going to call when I factor that out. So here's the first thing I'm going to do. I'm going to rewrite this as minus 3 times the cosine. Then factor out the 2 pi, the b, and get it on the outside of the parentheses. Still your b. And that leaves you an x in here plus, and when you divide 2 pi into 4 pi, you get 2. just the number 2. Not 2 pi, just 2. Now, that's what I'm going to analyze. Your little a here is -3. Now this implies that your amplitude is the absolute value of that. That would be 3. Okay, this now is your b is equal to 2 pi. And if you remember, your period is defined to be 2 pi over b, which is 2 pi over 2 pi, which is 1. Not 1 pi, 1. All right. This is your phase, what I'm now calling the phase shift. That's what I'm calling C. They've been calling it phase shift all along. C is equal to 2. That to me means phase shift is 2. Now this is a plus. Remember, normally it's a minus, so this will be, well, actually the C also is a minus because it's normally, drives me nuts. Okay. This thing keeps popping up here, which I do not want. I don't want to see it. And every time I try to put the minus sign in there, it pops up instead. See? Okay, I think I got it in there that time. Nope. Okay, those are minus signs in there. Your phase shift is a -2. All right, go back to period, and remember our intervals is the period over 4. So it'll be 1 over 4. So here is my graph. That's supposed to be a vertical line. For some reason, I'm not able to draw a vertical line. It never comes up vertical. So our intervals are 1/4. So it's going to be 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4. Minus 1/4, minus 2/4, minus 3/4, minus 4/4, minus 5/4, minus 6/4, minus 7/4, minus 8/4, minus 9/4. And why don't we just go and do these in quarters too? No, we can't do quarters. Okay. We're going to do 3 up and 3 down. Okay. 1, 2, and 3. -1, -2, and -3. Okay. Let's go on and put these in. This is 1/4, 1/2, 1, 1, 2, 3, 4, 2, and so on. This is -1/4, -1/2, -1, 1, 2, 3, 4, -2. Sorry. All right. Now, start with the phase shift. It's -2. Whoa, that's way over here. Where does cosine normally begin? Because your function is cosine. Cosine normally begins at 1. But this has an amplitude of 3. But the a is -3. So the cosine, this one's going to start at -3 down here. At 2, it's going to be -3. Okay. Now, it comes up at your interval to be 0. Okay. Goes up to +3. Down to 0. Oh, and here comes, Alondro. Good to have him back. I thought, because they were already here, I think was first one in the class today, and must have gotten bumped out or had to leave for some reason. So welcome back. Okay, then you go down, we got the 0 down here to -3 again. Okay, up to 0, up to plus 3, down to 0, down to minus 3, up to 0, up to plus 3, down to 0, down to minus 3, up to 0, up to plus 3, down to 0, down to minus 3, up to 0, up to plus 3. This is going to be really... Say again?
Mr. Fowler,
Yes.
do you know your screen is green?
My screen is green.
Yeah, your screen is like glitchy right now. It's showing green for us.
Oh, okay, so everybody.
Is that everybody? Because my screen is perfectly white. Okay. And I do not know what to do to change it because it's everybody's that way.
Yes.
Yes.
Is there anybody who doesn't have a green screen? I have no idea how to do this. If mine were green, I'd know what to do, but well, no, I wouldn't know what to do, but I knew I had to do something. But see, I don't, I do not have, and I was going to do. So what is my drawing here? My pen is red. What is the drawing? Is that in red or is that in green? Okay. I have no idea what that indicates. Does anyone out there see something that looks like a normal screen? Any one of you? All of you, it's wacko. Okay. Let me try this. Let me go to the whiteboard. That's what we had before. That was that sine function with a, what does that look like to you?
It's right.
You can see that.
Yeah.
Wow. And let me go back to the other one just to see if that changed. How about that?
Yes.
Okay. Okay. Next time that happens, remind me, go to whiteboard and come back again. That must be what happens. I don't know. Had it been that way for a long time before someone said something, or did it just happen? Okay. My guess is something to do with the weather, but I don't know. I really don't know. All right. So let's draw this curve in here. Now this is going to be really hard not to make them pointed because they're so close together. This is what this cosine curve looks like. Whoops, I went too far on that one. Obviously my drawing leaves a whole lot to be desired. Okay, always try to have them nice and smooth curves, and it just continues on and on and on. All right, so there's the graph of it. Now, here's a couple things to note. What we were counting as kind of like the phase shift before, but because we had a 2 pi here and a 4 pi there, sort of ignore that, but that would have been 2 phases over. Well, look at us. 1, 2 phases over, and sure enough it was. Okay, except we're not in terms of pi because we divide by 2 pi, we're in just terms of numbers. So whatever your numbers are, whatever your thing is, follow the rules. Just do the amplitude, the A first, determine the amplitude, the B next, determine the period. Also when you do the period, do the interval. The C next is the phase shift. Now if you did it their way, you would have had this thing, the C, the phase shift would have been C divided by 2 pi, but I divided by 2 pi early on, So this gives us our C right here. But remember, the standard form is x minus C, and since this is a plus, that makes the C being negative. Means the C is shifted over here 2 units to the left, and then you begin your cosine. Normally you would begin at plus 1, but the amplitude was 3, but it's a negative 3, so that made you start at the bottom, reflecting across the x-axis, and you go from there on. And then every interval you hit one of your key points, from a minimum to 0 to maximum to 0 to minimum to 0 to maximum. Our minimum and maximum are minus 3 and plus 3. So you just sketch the graph. All right, any questions on that? That's how I did it. I know they're going to do it slightly differently. I think my way's easier. If you like their way better, go for it. You paid the money. You can interpret any way you want. Okay? They start, oh, and by the way, I learned this yesterday. This was so amazing. My old program I had was called Tegrity, and it had these things at the bottom, and I guess I flashed back yesterday and went down here and found out I can erase the ink on the screen. Before I said on this screen I can't erase it. I can. I can change colors. It's just amazing what I can do down there. All right, so the amplitude is 3, absolute value of your A. The period is 2 pi. I'm sorry, the B is 2 pi. The period is 2 pi over 2 pi over B, and that turns out being 1. And as soon as I do that, I like to then say my interval is going to be divide the period by 4, and that would give you an interval of 1/4. Okay. Now, they like to go through and solve these equations, and it's perfectly legitimate way to doing it. It's just so much more difficult to do it their way, it seems like to me. But this comes out being x equal minus 2. That's where your left-hand endpoint of your first period is going to be. The right-hand endpoint would be 2 pi x plus 4 pi equal 2 pi, which normally that's the period for a cosine, a normal cosine. And then you have to solve that. You subtract 4 pi on like that, and that gives you x equal -1. So now your interval is -2 to -1. That corresponds to 1 cycle of the graph. Split that into 4 pieces, and you have a quarter. That I would have already done that. Dividing that interval into 4 equal parts produces -2, -3, that first one, because you start normally at a +1 for cosine, but this was a 3, but it's a -3, so you start down here. Then the next one is going to be 1/4 of unit from -2. See, this is such an awkward way to do it. You're back up to your intercept, go up another, go to the right another quarter, and you're at -3/2, and you're at +3, -5/4, you're down to 0 again, and -1, you're back here. So there's 1 cycle, and just continue. If you just did it the other way, you don't have to mess with these as much. You just do them on the graph. You're still doing it, you know. Notice I said you start down here and then go to your, for your one interval, which is 1/4 of a period, you go to a 0, a max, a 0, a min, a 0, a max, a 0, a min, a 0, a max, a 0, a min, a 0, a min, a 0 here, and then a max here, and then back to a 0 here. You just plot the points and connect the dots. That's all you have to do, okay? And one more up here, and you're back at a 0 again. Any questions on that? Figure out what your letters are, what that tells you about amplitude, period, and phase shift, and then get your first place where it needs to be, first point where it needs to be. Cosine normally would be at the max, The -3 puts it at the min, and down here at -3 at the min, and then from there on you follow your pattern. You just do that. It's that simple. Okay. Now, that was example 5. Following example 5, there's another checkpoint. Please do your checkpoints. Now, they don't have all this verbiage in the book, but I believe this is starting the lower part of the middle of page 302. The final type of transformation is the vertical translation caused by the constant d. Now, for some reason, they put that d in front. If I were doing it, I'd put it plus d back here, okay? Because then you'd have A, B, C, and D. But they put the D in front, which is perfectly fine. There's no problem with doing that. Perfectly fine. And then the D here plus A cosine B x minus C. Of course, I always factor the B out and make the new C that's left here the real phase shift. They have to do C over B as the new phase shift. The shift D units up if D is positive, D units down if D is negative. Remember, your vertical translations follow the same sign. If D is positive, you're going up. D is negative, you're going down. In other words, the graph oscillates about the horizontal line y is equal to D instead of the x-axis. So basically, the D is just shifting everything either up or down. Okay. Now, they say that and then skip example 6. So let's go back and do example 6. So let me pull back up. Let me make sure I still have 16 students here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Got it. All right, good deal. Just missing one. And hopefully he can make it in. Okay. Anyone need the old drawing here still? Can I erase? Okay, I'm clearing that drawing. Okay. And here's example 6. Sketch the graph of y is equal to 2 plus 3 cosine 2x. Okay. Now, again, as always, I identify my letters. If I could find my pen, there it is. Here, the A is equal to 3. That means the amplitude is 3. Here, the B, yuck. Okay. The B is equal to 2. That implies that the period is 2 pi over 2. Well, the 2's go out, and that leaves you just pi. Once I have the period of that, then I'll do the intervals is a quarter of that. So if the period is pi, the interval is pi quarters. Okay, pi divided by 4. Your C here, this is aggravating. The C here is 0. You don't see a C, it's not there. There is no phase shift. And then they come around to the front here and do D is equal to 2. That means your vertical shift is upward 2 units. Okay, so let's do your, wow, I came closer to being vertical that time. I'd much rather be horizontal. Okay, never mind. There we go. All right. Now, let's just tack in. Your interval is going to be pi quarters. Let's call it 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi, 8/4 pi, 9/4 pi, 10/4 pi, 11/4 pi, maybe even 12/4 pi, minus 1/4 pi, minus 2/4 pi, minus 3/4 pi, minus 4/4 pi, minus 5/4 pi, minus 6/4 pi, minus 7/4 pi, minus 8/4 pi, minus 9/4 pi, and maybe even get in a minus 10th/4 pi. So I'm going to fill those in. Pi fourths, pi halves, pi, 1, 2, 3, 4, 2 pi, 1, 2, 3, 4, 3 pi. Excuse me. Getting so I can't breathe again. Hold on. I don't know if that really helps. Maybe it's a placebo, but it makes me feel better anyway. That's the 3 pi, and that's an ugly 3 pi, but this pen just will not draw a 3 well. Over on this side, minus pi fourths, minus pi halves, minus pi, minus 2 pi. I don't think I'll need any further than that. All right, now the vertical axis is one that's of some interest. The amplitude is 3, our phase shift is 2, so we're going to have to go up 5. So let's mark, mark this as being 5, and this will make this a 2 and a 3 and a 4 and a 1. I don't think we'll need that many down below, so let's just mark a few here. We won't need these at all, but I'll just mark them. So this will be a minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. We're not going to need those at all. This will be a 1, 2, 3, 4, 5. We will need all those. Now, start with your shifts. Your D is 2. So here is the D. That's going to make this our new equilibrium position. D equal to is our new baseline, you might say. That's what everything is going to be measured along, resulting in. Okay? Now, that's your phase shift, your vertical shift. If you'd had a phase shift, you're going to move from there. We're not. Okay, cosine normally starts at +1, but this has an amplitude of 3, so from this new baseline we go up 3, and that's why we needed the 5 there. Okay. And then you go your interval to the right, and you go down to what would have been your intercept is now at your new baseline. Okay. Then from there you go down your next, your amplitude in the bottom, that's 3 more units. That's 1, 2, 3. So you go down to -1 here. Then up to 0, up to the max, down to the baseline, down to your min. Your min is now -1. Up to your baseline, up to your max, down to your baseline. Yuck! Okay, down to your min, up to your baseline, and then up to your max. Okay? Same way in the other direction, down to your baseline. This drives me nuts. Down to the baseline. Down to, oops, I went to the wrong baseline. There's your baseline. Down to your minimum here. Up to your baseline here. Up to your max here. Down to your baseline here. Down to your minimum here. Up to your baseline here. Up to the max here. Down to your baseline here. Yuck. And down to your minimum. Oops, I went to the wrong baseline again. There's your baseline, and then here's your minimum here. Alright, so your curve, look, this is not going well. I'm trying to draw too rapidly. Yuck. You get the idea. My lines are not very smooth, continuous, clear, or anything else like that. Always try to make your mountain smooth and your valley smooth. Goodness gracious. This is taking forever. Okay. That's what it looks like. Because there's no phase shift, you start where cosine would normally start at its maximum. But there is a vertical shift, so your baseline goes up 2. You have an amplitude of 3, so it goes up 3 above that and 3 below that baseline. So that goes from positive 5 to minus 1. And then your 2x, that means you have a horizontal squeeze, because this 2 is greater than 1. That anything in the x direction is opposite, so that's a squeeze by 1/2 of what it would have been. You normally would have had a period of 2 pi. We now have a period of pi, going from this point to that point in pi, that point to that point in pi, that point to that point in pi, and so on and so forth. Any questions on that? That was your example 6. No. Where was that? Oh yeah, it is your example 6, and you'll see that in the book as well. If you can't look at your book, let me show you how theirs look like. Just because mine may not be the cleanest drawing in the world, that's it. And this is your baseline here, the dotted line. There's your axis down here. So you're going from the minimum -1 to the maximum +5. And you see we're just like we did. Okay? I did a few more periods than they did. Why, I'm not sure, but I did. All right, any questions on example 6? As always, it's the checkpoint at the end of every example. Please do the checkpoints. Okay, now we go back to the slide. Excuse me. And I think that's it there. And we go to mathematical modeling. I would call it trigonometric modeling, okay? This table, this is example 7, shows the depth in feet of the water at the end of a dock at various times during a morning, where t = 0 corresponds to midnight. Okay. Now, basically what we're dealing with is the tides. The tides are pretty close to being sinusoidal curves. Okay. Now, what we see here, someone went out and took it. At midnight, the depth was 3.4 feet. At 2 o'clock, it was 8.7 feet. At 4 o'clock, it was 11.3 feet. At 6 o'clock, it was 9.1 feet. 8 o'clock was 3.8 feet, 10 o'clock 0.1 foot, and 12 o'clock 1.2 feet. All right. Oh, I meant to tell y'all this too. I told my last class. Oh, I forgot. I have my phone up here. Okay. My watch, the battery died and it's recharging now, so I didn't have the watch on, and when I'm on PowerPoint I can't see the time, the clock on my computer, but I forgot I have my phone here and I can see the clock anytime I want to, so I'll bring it in sight here. Alright, so what are we going to do? Okay, that's the table. Here's what the problem says to do. Use a trigonometric function to model the data. Okay, so let's go back here and identify some key points. Now this is not going to necessarily be exact, but it should be representative. Okay, key points. Here, where I've got the wrong side of the pen. This certainly looks like a max, right? This certainly looks like a min. Okay. Oh, we may have somebody coming in. Let me see. Well, for some reason, I don't know what's going on here with this. No, we don't have anyone else coming in. Okay. It's just that taskbar at the bottom, which I don't think you can see, just decided to start floating around some. It's, boy, this thing is doing weirdly today. All right. Now, what that indicates to me, and this is just approximate, not necessarily true, could be the max was more like at 4:15, but we didn't take it at 4:15. So all we can do is model with 4 o'clock being the max. Okay? Now, if you remember the definition of amplitude, the amplitude was half the difference between the max and the min. So let's first take the difference between the max and the min. 11.3 minus 0.1 would give you 11.2, and half of that would be 5.6. That's going to be our amplitude. Okay, that's going to be our amplitude. Now, if you think also, and by the way, that's going to be, amplitude is represented by A. So that's going to be our letter A when we go to model the data with a trig function. The A is going to be 5.6, little a. All right. Now, let's go back. Oh, they don't show it. I forgot. We did it. Let's go back here. Okay. If we had what I'm trying to do is get you to see what the D is going to be. The D is going to be the average between 5 and minus 1. 5 plus minus 1 would be 4. Divide by 2, and that gave you 2. So the D is going to be the average between your max and your min. Does that make sense? It's directly halfway between the max and the min. So on this problem, what we're going to do is add the max and min together. 11.3 plus 0.1, that's 11.4, and then take half of that because it's the average, and that's 5.7. So that's your D. That's the vertical shift upward. Okay. Now, your independent variable here is T, and if you think about it, the period, let's go back another slide or two. We don't have to go to the one we just did, but this one, okay? Your period is between this point and that point, right? That's one period, because you go all the values in between the two and you're back where you started from. Well, we don't have a full period on that other thing. We have from here to here. Well, that's exactly half of a period. So what we have here, the time interval between, where is my pen? There we go. The time interval between here and there, that's 6 hours. So our period is equal to 12 hours, right? Because the max to min, that's going to be half of a period. So the full period is going to be 12 hours. And what was our period? Period is 2 pi over b. So 12 is equal to 2 pi over b. Solve for b, and you get b is equal to, let's write it this way, b over 2 pi is equal to 1 over 12. We just reciprocated both of those. So this would give you b is equal to 2 pi over 12, which would be pi over 6. So your b is pi over 6. All right. Now, the one last thing we need to do is find out where our equilibrium point is. Well, we know that the D is, but what we want to know is where we're starting this mess. And if your period is I don't know who that is, so I'm going to put, that's the disadvantage of having the phone handy. It rings all the time. Okay. Your equilibrium is going to be half of that, and this was at 3 hours. Since this is a 6 hour here would be when you would be at your equilibrium. 3 hours here or 3 hours here. Okay, so this would be at 7 o'clock and at 1 o'clock. So since 1 o'clock is awfully close to 0, let's say we have a phase shift of 1. So your C is going to be 1. Now, using that as my phase shift, that defines me to be the sine. So what are we going to have? Y, that's the depth, is equal to going to, and I like to start with A. We determine our A to be 5.6 times the sine of, I like to do the B on the outside, and the B was pi 6 times T minus, and what was our phase shift? 1. Plus, and our D was 5.7. All right, that looks like my mathematical model. I got the A from here, the B from over here, the C from here and the D from there, and just plug it in. There's my model. Y is equal to 5.6 sine of pi 6 t minus 1 plus 5.7. Now, I'm going to tell you what the book's going to do before they do it. They're going to use cosine. Why? I have no idea, because that's more of a phase shift in the opposite direction. But that's okay. Sine and cosine shapes are exactly the same, just where you want to begin. The other thing they're going to do, they're not going to use pi 6. They're going to use a fractional, a decimal form of pi 6, and I'll tell you what that is right now. Okay, I've got to turn my phone sideways so I can get a pi to show up here, and that would be pi divided by 6 equal 0.524, something like that. That's what I get as pi 6, 0.524. Now again, yeah, I think that's what they're going to use. So stand by for that and get used to those numbers. Why they do it this way, I don't know. Seems like it'd be better to use pi 6. It just makes more sense. Okay. Now, let's see how they did on their model. There's our model. Okay. There's a change of tides. They actually drew the graph. Okay. And what was their model? They used cosine, and they put the B in with the C. So they did all this same stuff we did. Okay. 5.6 was their A. The time of minimum, time of maximum, twice that is the period. That was 12, which implies B is 2 pi over 12, which is, and there they did it, 0.524. Why they didn't say pi 6, I don't know. Okay, but there's the B. Now their C, they're using cosine, so they have a different C from we did. But theirs would have been 2 if they'd have done it right. They put 2.094 because they approximated this, and then therefore the error carries into this. Okay, we'll see we get the same answer, and the average depth is 5.7. Same thing we did. So their cosine is 5.6 cosine. We have 5.6 times sine. Pi 6, well, I pulled the pi 6 outside here, and then we had a phase shift of -1. They had -2 because they did cosine. And then this is the same. So basically our formulas look the same. So let's go back. That was the first part. Do the mathematical model. The second thing, so here I'll write down mine. Y is equal to 5.6 times the sine of pi 6, that's the B, times t minus 1 plus 5.7. That's our mathematical model, where t is the time since midnight. Okay? Well, they said 9 a.m. Find the depths in. Well, plug and chug. Y is equal to 5.6 times the sine of pi 6 times 9 minus 1 is 8 plus 5.7. Okay, pull out the handy dandy calculator. Get it activated again here. Turn it sideways so you can use the pi. Now if they use theirs, you wouldn't have to, yeah, you still need it that way for sines. Okay, so I'm going to have to be careful here. That is 5.6 times. Now I've got to do the sine of this. So I'm going to do 6, 8, 6 is going to be 4/3. So I'm going to open a parentheses, okay, and do a 4 times pi divided by 3. Close parentheses and take the sign. Ooh boy, I'd better be in radian mode. I am. Whew, good, because this is in radian mode, folks. Take the sign of that and then add to it 5.7. So that gave me my height, the depth at 9 a.m. I got about 0.85. Okay, let's go to when they did the graph here. 9 a.m. would have been right about, there's 8, 10, 12, so 9 would have been right here, and that looks just about to be not exact. In fact, that looks a little bit greater than 1. We're a little less than 1. Well, I got 0.85. Let's see what they got when they did it on using their cosine. Okay. Okay. So there's their model. Let's do us with 9 in there. And they got 0.84. I got 0.85. And the reason mine's a little bit better is because they rounded. Okay, but you see we're right in the same ballpark. So there was that one. The second question was at 3 p.m. Well, how many hours is that since midnight? 12 will get you to noon, 3 more are 15. So this will then be, the second one here is y is equal to 5.6 times the sine of pi 6 times, what did I say, 15? Yeah, plus, oops, no, I forgot to subtract 1, 14. No, that's not what I wanted to do. I want this down here. Remember I said we couldn't erase? I found, oh, didn't show up right. There we go. I found a way to erase. Okay. It's 15 minus 1, which would be 14, plus 5.7. All right. Pull out the calculator. Make sure you're in radian mode. I am. And we've got, I'm going to clear that just so it won't be in the way. 5.6 times, now I'm going to open parentheses for me to do my calculation. 14/6 would be 7/3, so that would be 7 times pi divided by 3. Close the parentheses, then take the sine of that in radian mode, and then add to that 5.7. Just plug it in the formula, okay? Equal, I got the tide then to be, the depth to be 10.5, approximately 10.55 in fact, okay, or close to that, 10.55. Let's see what the graph looks like. Now remember, it has a 12-hour period, so 3 o'clock would be right about there, and that's 10 point, it looks like that could easily be 10.5. Let's see what the calculation gives us, gives them doing their way. So now they're going to plug a 15 in there. They got 10.57. I got 10.55. Okay, right on the money. Their error shows up because this is a round off here. So they rounded to 3 digits. Notice to 3 digits we're still in the same ballpark. The 4th digit they're getting off. Okay, so if they're rounding to 3 digits, they shouldn't round the answer to 4 digits. Okay, all right, what's the next question? Now this one's a little bit tougher to do. This says a boat needs at least 10 feet of water to moor at the dock. During what times in the afternoon can it safely dock? Okay, well the depth was 10. So basically what we're doing here, and I'll tell you ahead of time, they're doing it graphically. I'm going to show you how to do it mathematically. Okay, so the y here is 10. 10 is equal to 5.6 times the sine of pi 6 times t minus 1. Okay, forgot that. Plus 5.7. Now, I think I won't do that because this is just going to take us too long to do. And what it would involve was an inverse cosine. Inverse sine. You don't know how to do that yet, so I was going to take you through that, but let's just hang off on it, okay? But what you would do is subtract 5.7 from both sides, then divide by 5.6, and then take an inverse sine of what you have left there and give you an angle here, and then that angle in radians, convert that, divide by pi, multiply by 6. When you finally get this, add 1 to it. And that would be what you would do. But since we don't know how to do inverse sines, we won't do it. Here's how they do it. Okay? They basically look at this and say, now this is in the morning time, your 10 feet of water will be basically from here to there. Well, guess what? It's a sinusoidal curve. It's going to come on up and then peak again here in the afternoon at about that same time. So this, and this is really hard to do here, but I'll let you see what they're doing. They do it graphically. There's a 9 o'clock. There's a 3 o'clock. Using a graphing utility, that's what they do. Graph the model with a line y is equal to 10. There's that line y is equal to 10. See where they intersect. It was 14.7 hours and 17.3 hours. Okay, so that's from a graphing calculator, which is perfectly fine to use. Well, 14.7 hours. Well, 14 is going to be 2 o'clock in the afternoon. And 0.7 times 60 would be 42. 2:42 in the afternoon, that's PM, to 17.3. Well, 17 would be 5 o'clock. 0.3 times 60 would be 18. So those are the 2 times in the afternoon between 2:42 and 5:18. That's when you have at least 10. Okay, Zora has a question. What is it?
You know we over time, Dr.
No, I didn't know that. I didn't have my clock. Okay, we'll end. We finished this one. You can go back and review it if you want to. There is a checkpoint. Please do that. We'll start next time with the vocabulary in 4.5. And let me give you homework. Homework here would be any of the questions 5 through 11, they're all at Calc Chat, 7's at Calc View. 13 through 23, odds 13 to 23, they're all at Calc Chat. 25 to 29, all at Calc Chat, 27's at Calc View. Oh, this is on page 304, 305, 306, and 307. There's a lot of them here. Okay. Any of the odds 31 through 51, they're all at Calc Chat, 49's at Calc View. Two other people have raised hands. What's your question?
I was wondering what is due on Sunday?
There's nothing due on Sunday in my book. Did Blackboard say that something was due on Sunday?
Yeah, it says something
A
about
test? Okay. If I can find what's due, I'll change it. Blackboard puts those due dates in there, and if I don't catch it when it does it, they show up. Forget anything Blackboard's doing there. I didn't put any due date for Sunday. In fact, I don't put due dates in anywhere. Yes, somebody else raised a hand. Izora has hers up and somebody else. Maybe two other people. What are the other questions? Oh, okay. Was that the third person's question? Okay. Let me finish with the homework exercise, then I'll come back and show you the test. I think I got through 51. Any of the odds, 53 to 57, they're all at Calc Chat. 55's at Calc View. 59 to 63, all at Calc Chat. 65 or 67, both at Calc Chat. 65's at Calc View. 69 to 71, both at Calc Chat. 71's at Calc View. 73's at Calc Chat. Any of the odds 75 through 77, all at Calc Chat. 75's at Calc View. 79 through 85, they're all at Calc Chat. 87 or 89, they're both at Calc Chat. 91 at Calc Chat. 93 or 95, both at Calc Chat. Okay, that's the homework. Now, let's take you to a new screen share here if it's still up. I think it is. Well, it was up. It's gone now. Let me take a moment here. I'm going to stop sharing for just a minute so I can get this off the screen and end the slideshow here. Discard that. All right, now I can get to it. Okay. Okay. It's going to take me a couple minutes here to get down to Math 113. Here we are. Okay, I'm going to pull up Zoom again. Okay. And I'm going to pull up the screen share again. Hopefully it's going to show. Yeah, here we go. Here is, now, I don't know if this is in your way. I'm going to try to ignore as much as possible. Okay, you can see the Math 113 Blackboard page, right? Now, I'm going to try to show you where the test is. Okay, come down here to weekly activities. It may not be here. I don't remember. Whoever did this really stupid template kind of botched it up. Now, I can't remember. Did I give it to you week 5 or week 6?
I think it's on 6.
Okay, I believe you're right. Okay. Okay. See week 6 homework there. Here's where test 1 should be. Yuck. Wouldn't you know that gets right in the way. Okay, test 1 should be. I click on that, and it wouldn't let me go here. I couldn't put it there. I thought that was the case. So forget that. Now I'm going to move you all out of the way again. You can't see it, but yo, I lost you, but it's okay. Let's get out of this. Out of that. Okay. You see the envelope here? That's Blackboard Messages. I'm back at the very home page, basically, of our class. You see Messages? Click on Messages. Okay? There's a message from me. Attached is test 1. I tried to post it on week 6, test 1, but Blackboard wouldn't let me. So click on my name. It's underlined, so you can click on that. And here it is. You go to the 3 dots to the right. You see those? Click on the 3 dots. They call it the elliptical. I don't know why that's not an ellipse. Okay? Download the original file. Click on that. When you do that, it goes down to the lower left corner and starts downloading. I think it's downloaded now, so click on that, and there will be, okay, you may have to rotate it. I believe that's I thought that was yeah, here we go. Rotate clockwise. Oops, rotate counterclockwise. Rotate counterclockwise. Okay, there's the test. There's page 1. And remember, somebody asked on Thursday, that's 15/17 and 18/17. Okay, that one, they had it wrong in the test bank. I had to correct it. Okay, and then here's page 2. There's page 2 of the test. It's a PDF format, so you probably have to print it off if you can, or whatever you need to do. You can send it back to me in PDF. You can send it back to me as a picture. You can type in the answers and send them back to me any way you want to. You can send it through message. You can send it on that week 6 test 1. I think you can post things there if you want to. You can, or you can attach it to an email and send it to me that way. I check them all, and that's how you get it back to me. But there's the test under Blackboard Messages, and it's a PDF file. Did that answer your question? All right. Are there any others before we shut it down for today?
Mr. Fowler,
Yes.
our homework questions, we just post them under the week.
You certainly can post them there if you want to. You can attach those to a Blackboard message, or you can attach them to an email. However you want to send them to me, I'll try to find them. Okay, so whichever way you want to do it. If one of them's really easy for you to do it that way. If one of them's really complicated, avoid that one. Do it one of the other 2 ways. However you can get them to me. Okay. Any other? And if you are sending them by either message or email, be sure your name will be there, but be sure you, on your homework, put your name and also which week it is. Now, if you're doing it under the weeks, I'll know what week it is. But if you're doing it by message or email, then be sure you put your name and the week, and that way I'll know it. Yeah. Okay, was there another question?
It's going to tell you when we submit something in that week.
I have to go search for it, but yeah, I try to do that every day. I don't always get to every day, but I try to do it. Usually I catch up some on Friday and get things caught up then. Now this past Friday I didn't, because we were driving to Georgia on Friday and I couldn't do any of that. We got to Georgia and our internet was completely out. It was always weak, but it was completely out. And it came back on late Sunday, and so I didn't have time to do anything there. And we didn't have a printer anyway, so I had to wait till we got back here. So, any other questions? Okay, I'm going to stop the sharing. And I have to stop the sharing because I've got class starting 3 minutes ago. So, if there are any other questions, get them in a hurry, okay? All right. Well, then we'll see you on Thursday, okay? Did I answer all the raised hands? I saw several of them up there, but I couldn't tell who it was because it didn't show who was asking. All right. We'll see you Thursday. Bye-bye. Hey, sorry y'all had to wait. I know Kira was waiting. I think Jesus just got here. I'm not sure, but maybe you were waiting too. I don't know. But in my last class, they had a bunch of questions after time ran out, and they just kept asking. And I finally said, hey, I've got another class that started 3 minutes ago, so I've got to get off now. So sorry that. So Kira's here and Jesus is here. So we got both ends of the bookends. I just don't have the guy in the middle. Okay, hopefully James will be coming in. So sorry if you were waiting long. Were you waiting long, Kira? I'm sorry. It's complicated by the issue that I have. I got Zoom up, but then nobody was here, and I thought, and since I have only 15 minutes between classes, I couldn't go another hour and 15 minutes without running to the restroom. But we're having plumbing problems upstairs, so I have to go downstairs to go to the bathroom. And so I rushed down there to do that and then rushed back up. And that's why you had to wait. But anyway, sorry about that. All right. Oh, man.